Hello everyone. Before starting the lesson, try this warm-up. Draw all the different pizzas that can be created by choosing all, some, or none of the available toppings. So here we have no toppings at all. There's only one choice. If you have cheese as a topping, you could have cheese or no cheese. So there's two possible pizzas that you can have. Now you have a choice with cheese or pepperoni. So how many different pizzas could you make? With cheese, pepperoni, and mushrooms, how many different pizzas can you make? And with cheese, pepperoni, mushrooms, and bacon, how many different pizzas can you make? So pause the video and see what you can come up with for this. Well, if cheese and pepperoni are the two toppings available, you could have a pizza with cheese, a pizza with pepperoni, a pizza with cheese and pepperoni, or a pizza with none of those options. So there's 4 different pizzas you could make. See how we're doing this? You can have one of the toppings, you can have some of the toppings together, or you can have no toppings at all. So for the next one, you can have cheese, pepperoni, or mushrooms as possible toppings. Well, you could have a cheese pizza, one with only pepperoni, one with only mushrooms, or one with cheese and pepperoni, or one with cheese and mushrooms, or one with just pepperoni and mushrooms, or one with all 3 toppings, or one with no toppings at all. So if you have 3 different toppings as choices, there's 8 possible pizzas that you can make. And when you have 4 different toppings available, there's 16 possible pizzas that you can make. So I want you to notice something. Every time I increased the number of toppings available by 1, I doubled the number of pizzas that you could make. This is an example of something called exponential growth. In this lesson, we're going to talk about exponential growth and decay. So we're going to determine if a function is linear, quadratic, or exponential based on the table of values, and we're going to recognize if a function is exponential growth or exponential decay. So how can you tell if a function is linear, quadratic, or exponential? Well, let's look at the warm-up examples again. When we had 0 toppings available, there was 1 different pizza we could make. When there was 1 topping available, we could make 2 different kinds of pizzas, etc. We already went through how we got these numbers. To see if this is a linear function, I can test the first differences. 2 minus 1 is 1, 4 minus 2 is 2, 8 minus 4 is 4, 16 minus 8 is 8. So, as I increase from one row to the next on my table of values, I'm increasing by 1, then 2, then 4, then 8. So I'm not increasing by the same rate of change. So this is not linear. Next, I can check the second differences. So from 1 to 2, I'm going up 1. From 2 to 4, going up 2. From 4 to 8, I'm going up 4. This is not a constant rate of change again. So because the second differences are not constant, I can tell this is not a quadratic function. So what I'm going to do instead now is to see if the ratio of my first differences is constant. So from 1 to 2, I'm multiplying by 2. From 2 to 4, I'm multiplying by 2. From 4 to 8, I'm multiplying by 2. If your first differences are multiplied by a constant ratio, then you have an exponential function. So again, check your first differences. If they are constant, you have a linear function. If not, try your second differences. If they're constant, then you have a quadratic function. If not, try the ratio between your first differences. 2 divided by 1 was 2, 4 divided by 2 is 2, 8 divided by 4 is 2. If that number is constant, then you're dealing with an exponential function. So that's how you can tell whether you're dealing with a linear, quadratic, or exponential function based on a table of values. Now, this example just is really covering a basic skill and just revisiting it. If you have a table of values, how do you turn that into a graph? Well, you just take each ordered pair of x, y values in your table and turn that into coordinates of a point. and then you're just plotting those points on the graph. So -2, 0.25 would be here. -1, 0.5 would be here. 0, 1 is here. 1, 2, 2, 4, 3, 8, and 4, 16 would be somewhere up here. Doesn't fit on the grid. Anyway, look at the points you plotted and just notice something. As I go to the right on the graph, all my y values just keep doubling. 1, 2, doubles to get 4, doubles to get 8, doubles to be 16, etc. If I work backwards, each value before it is half as much. This is 8, half of that is 4, half of that is 2, half of that is 1, half of that is a half of that is a quarter, 0.25. Half of that would be an eighth, and a 16th, then 1 over 32, 1 over 64, 1 over 128, etc. It's just getting smaller and smaller and smaller. Is the y value ever going to reach 0? No, but it's going to get really, really close because the numbers keep getting smaller and smaller and smaller. So your graph is going to look something like this. Remember to put arrowheads to indicate that this function keeps going in either direction. Now, this is what an exponential function looks like. Is this exponential growth or decay? What do you think? Well, it's growth because as you read the graph from left to right, what's happening? The values are growing. The y values are getting bigger. So if the y values are getting bigger as you read from left to right, then that's a growth curve. This is exponential growth. Decay would be the opposite if your y values are decreasing as you read the graph from left to right. So let's apply this. In example 3, vehicles typically depreciate in value by 20% per year. I want to stop there for a second and just go over what that means. If the value of something depreciates, it means the value is decreasing over time. So vehicles depreciate in value by 20% per year. That means every year they are worth 20% less than what they were the year before. That's typically how it works with vehicles. If you bought a 2020 Dodge Ram for $34,000, how much would it be worth after 5 years? And then we're going to sketch a graph, what that would look like. So we can see in year 0, in 2020, the value of the truck was $34,000. How much would it be worth 1 year later, 2 years later, 3 years, 4 years, 5 years later? Keeping in mind that it's depreciating by 20% per year. Pause the video and see if you can finish off this table of values here. If you need help getting started, look at it this way. If the value is depreciating by 20% per year, that means it's retaining 80% of its value from the previous year. 80% of 34,000 is 34,000 times 0.8, which gets you 27,200. So, if you're starting with a value of 34,000 and it depreciates by 20%, that means the value is now 27,200 1 year later. And you can keep that pattern going for the rest of the years. Then we get these values here. Now, if we were to sketch a graph of this, we would plot the year on the x-axis and the value of the truck on the y-axis. Okay, so in year 0, that's the year 2020, that would be here, the value was $34,000. So it's going to start high, and then it's going to get lower and lower and lower and lower. So I'm going to plot my y-intercept here, $34,000. Now, is it going to decrease by a constant rate? Would I have a straight line? No. It's going to be 80% of what it was in the previous year. So every time I increase the year by 1, I'm going to retain 80% of my height. This is exaggerated, of course, but your graph would look something like this. We see the value decreasing, but by less and less and less every year. Of course, again, I'm just saying this is an exaggerated graph. I don't have a sense of any scale here, but this would be a rough sketch. Okay, so is this exponential growth or decay? Well, pretty easy to figure that out. I'm decreasing from left to right, so this is exponential decay. So if you have an exponential decay graph, it'll look something like this. So we've talked about exponential growth and exponential decay, the differences between those graphs, and also how to know if you're dealing with linear, quadratic, or exponential functions based on their table of values. So practice with that, and if you need any help, just reach out.